So welcome to this VELUX webinar. This is the first webinar of a series of 6 this spring for our project development guide. My name is Thomas Graybeck. I'm the owner of GRAPHISOFT Center Denmark. I'm here with Shivani Mutatkar and later on also with Elham Beik. And we're gonna go through the different phases of this guide. Today the topic is early phase design, and we call it concept to BIM integration. And this should try to tie the project from the very early beginning and the early phases, but on the later webinars we'll go through the detailing part, the LCA calculation, the MEP design, and so on. So first webinar of a series. I will just share my screen so we can get the presentation going. I think we'll be here for about an hour. That's the plan at least. So the agenda today is to talk a little bit about how BIM works also for early sketching, something about microclimate analysis, material choices in an LCA lifecycle assessment concept, and then the VELUX BIM objects that are part of the project, visualization, and then there should be room for questions. So if you have any questions, please just write them in the chat, and we might answer some of them during the webinar in writing, or otherwise we'll wrap up with some answers for some of the questions. That's the plan for today. This whole project, doing a development guide. The idea is we do a test project and we try to do all the drawing material, go through all the different phases for the consultants. And we publish the drawing material as a PDF, but we also publish the ArchiCAD files and IFC files and other material that is part of the project. So you should go and visit our landing page on velux.com/project-development-guide. It's probably easier for you to read it here on the slide. So if you go there, it's a work in progress. So there's already a little bit about the webinar series. You'll be able to see the recordings later on. And there will be more and more materials. Hopefully there'll be a guidebook and some tutorial videos later this year. The project we're doing is inspired by the Home for Life project, which is a real-world building. It's been built for VELUX and Velfac in 2009 and was designed by art architects and Espersen consulting engineers. And I remember being a young architect, seeing this project as being the absolute showcase of sustainable housing at that time. And I think it still is a really good example of a great building that also performs really nice. But we just used it as inspiration, and then we have changed details on the building, and we definitely changed materials because of the new strict LCA demands in Denmark. Early phase BIM is something that is not widely used. Often in offices, architects tend to use SketchUp, Rhino, AutoCAD, all other kind of tools to do the early design. But there's still benefits of doing everything in a BIM content. That means you have all your information in one place. Multiple people can work in the same document, and you have schedules there also. BIM is also a perfect place to have all your material from the land surveyor and other ground material. So it's a good way to start the project. And I just had some bullets here of what the workflow could be. You start doing the terrain and surroundings. Then you add a volume, some early sketches, and you start detailing that volume until it becomes what is more like a real BIM project. And this is an example of our project. It's a really rough 3D volume with some terrain and surroundings. It's made from walls and slabs and roofs. And then later on, we start adding balconies and a little bit more detailed design, but it's still pretty rough, and that makes it easy to do changes along the way. The more detail you have on the project, like this one, the visualization model in the end of the sketch phase, if we want to do changes here, it will take some more time because we have to change a lot of small details. So the longer you can stay in a low detail mode, the easier it is to make changes for the project. You can also see we have furniture in the model and everything we need to deliver the drawings. So just to roll back a little bit, for the early phases when you have the volume, it could be done by a morph in ArchiCAD. But I prefer to use slabs and walls because sometimes it's easier to control, and I know that it's going to move to walls and slabs later on. For the first illustrations, I like to use the sketch tool, the sketch render in ArchiCAD, because it doesn't promise too much. It looks like no decisions have been made yet, and that's exactly what I want. Later on, when we have a little bit more details on the model, it could look strange with a really photorealistic render when there's no windows and doors in the model. So I like to do this white model render that looks like gypsum, but you still get a really good idea about the shape of the building. At one point, you need to make sure that the project is located according to real-world coordinates. And this is something that architects are really bad at. Often this is done too late, and it can be difficult to move your project when other participants are joining. So there's actually a pretty easy workflow for making sure that you share the right coordinates. And what you should do is you should get a land surveyor drawing and use it as an underlay. And that drawing normally has in Danish calls the land coordinate, which is a specific point in real world where everybody can link the project coordinates to. So how it works is you do a worksheet just to put the 2D DVG on. You XREF the DVG into this worksheet, and you make sure that it has the drawing's own origin and no specified origin. Then we just have to add it to the drawing, and now you can see the local base point is this small cross in ArchiCAD. So I just make a polyline that marks this spot so it's easy to find later on. And then I zoom in on the real drawing, which is located far away from the base point. So I can zoom out and I can find my marked spot. It can be a little bit difficult to move around when the distances are so large. Then I go to my ground floor on my real project and I trace reference this worksheet underneath, and I move the land survey drawing underneath my own model. I just need to make it pointing north like this. And then I need to move it so it's really precise. So I'll just move it pretty close, zoom in, make the model a little bit more transparent so I can see the land surveyor's drawing beneath, and here it snaps. So now the land surveyor's drawing is precisely located. I can see my base point as a small black cross. And if I turn on my survey point, which is used for this coordination of land coordinates, I can move that down to the origin of the land surveyor's DWG. That's done here. I zoom in, and now I'm really happy that I did this mark, so it's easy to find the 0.0 of the land surveyor's map. And now I have the real coordinate. So everything I do, I can choose when I import DVGs or when I export IFCs, if I want to align it with the survey point or the local base point. So now everything is set up. It took me 2 minutes, and it's not that difficult. But the later you wait to do it, the more difficult it will be when you have to coordinate with everybody else. So now I have my rough sketch model, and I can use it to do my site plan. I can use the more detailed model to do my furniture plans and my elevations. I can also do sections. Sometimes if the section looks a little bit with a little bit less detail and it's not detailed enough for me to present to somebody and make it look professional, I like to do the 3D details, the 3D sections instead, because it doesn't promise as much and it gives a really good idea about interior and room spaces, light, and so on. We also do some diagrams, and they're just added on top of the 3D model, so I get a lot of benefits of understanding the geometry, and I can do some simple analysis and diagrams. This one is going to be used later by Shivani and Elham for the microclimate analysis. Then the volume study before windows and doors was also used to do a 3D print, and I actually have it here. I know that the image of me is really small, but there is a 3D print, and this one is scale 1 to 200, and it's really fine. And the low detail level works really nice. So if I had a meeting with the client, I would always bring something like this. It doesn't have a high cost of printing. The printer is actually also pretty cheap. And there's no work in doing this. I just took the volume model and cut off part of the terrain to make it fit in the printer, exported it as a step file, opened it in the printer software and pressed print. So almost no work. It doesn't cost much to print, but it takes 27 hours for it to print this small model. That doesn't fit with architects. That would have to be well prepared and in good time. So that's the benefits and the disadvantages. I don't have the printer myself, so we had help from TMP Architectures, and they did the print for us. Thanks. So another export I have to do is an OBJ export or wavefront export, because the microclimate analysis is done in other softwares. So to get a 3D model that's easy to use, I just take my model in ArchiCAD, filter it with a layer combination, and then I actually turn off a few more layers. So I have a pretty clean model. And then I just go to Save As, and I choose a wavefront file format. And that's the one that's called OBJ. So you can be a little bit confused there. There's not much to determine in the export settings. So I just export, and everything is there. So that's kind of the BIM part. And as you probably noticed, I was saying ArchiCAD a lot, and that's because the project we did is done in ArchiCAD as the BIM platform. You could have chosen other BIM applications also, but that's the one that we of course like and promote. And it's easy to have everything in there. So when Shivani is finished with the microclimate analysis, that will also be moved into the drawing materials inside ArchiCAD. So we have all the layouts and everything is put together there with one point of all information in one point. So I think I'll let you speak about microclimate because I don't know anything about that.
Yeah, thanks, Thomas. So let's talk on how BIM can be used to conduct early stage microclimate analysis. So basically, it's possible to do the analysis to some extent in ArchiCAD, but it could be done further using other tools, which you can see on the screen. We've used Rhino, we've used Climate Studio to do a few analysis, and you could also use Grasshopper and Ladybug plugin to do further climate analysis. I would also like to take you through some key metrics. So this slide is actually introducing a few keywords that you can keep in mind. The first one is wind analysis. This helps us to understand the local wind conditions, either seasonally or annually, as you can see. And the sun path is actually defining the sun's movement throughout the year. This would then help identify window placement to get the best output, taking into mind wind speed, direction, and also the angle of the sun that's hitting the glazing. Next, we can look at incident radiation, and this is basically measuring the total solar energy on a surface, and this is measured in kilowatt hours per square meter, while sunlight hours show how long the areas are actually receiving direct sun, and these are measured in hours. And together, all these metrics are basically supporting informed, performance-driven design decisions. Now, you can see a lot of things on this slide, but let's look at the future and the current climate and see what information can we actually get from this. So let's look at the hourly heat map of the current weather and also the future weather according to the RCP 4.5, which is basically assuming a moderate climate scenario with a 3-degree temperature rise by 2100. We can see that the maximum temperature rise, the temperature is actually rising by 3 degrees, looking at the current versus the future climate scenario. And now let's look at what an energy efficient range can actually look for ventilation. So we've defined the range to be somewhere in between 14 degrees and 27 degrees. So anything below 14 degrees, we say that we're heating, and anything above 27 degrees, we say that we're cooling. And everything in between is basically free natural ventilation. So currently in Denmark is a heating heavy environment with approximately 47,290 heating degree hours, but the heating demand is expected to decrease by 12%, and the cooling demand is basically expected to increase by almost 2.5. Moreover, the potential hours for natural ventilation with energy efficiency in mind is expected to increase by approximately 22% looking at the future climate.
I don't think very many architects are aware of this, that they're designing with all the knowledge looking backwards instead of designing for the future.
Yeah, and I think this is a very good way of actually looking at how you can look at different microclimate studies and actually influence the early stage design. And I think this is a very good way of improving the performance of your design. But yeah, thanks for the question. And yeah, so basically now to summarize everything on this, designers can take an informed decision early on to minimize the risk by analyzing the outdoor temperatures over a year. And now we can also look at how we can use wind speed and direction for an analysis. So this is basically showing that the prevailing wind directions across the year and during the summer conditions. And we can see that the winds are predominantly coming from the west and the southwest. So to take advantage of this, our project has been designed keeping in mind that the openings are positioned to capture air from all these directions. And at the same time, our roof windows on both the north and the south side support to create cross and stack driven ventilation, improving the overall airflow of the building. So basically this strategy is allowing us to enhance natural ventilation while still maintaining a good indoor climate inside the building.
So when you told me before that we need probably twice as much cooling in the future than we did before, then it doesn't have to be air conditioning. It could also just be clever ventilation.
Exactly. And this is a way of how our roof windows can actually influence the design. And overall, this strategy is allowing us to enhance the whole natural ventilation and a good indoor climate and basically having a good informed decision. And now I would like to pass over to my colleague Elham, who would take you over through a few more steps in the analysis.
So while you're changing the mic, I think it's important just to remember this is not all done in BIM. So I think the BIM should be used when possible. It's a really nice place as a spine of the project to have all your information the same place, but it shouldn't be used when there's another tool that's better. And Grasshopper inside Rhino has a lot of benefits for environmental studies with all the Ladybug tools. And Ilham, you're going to show us some other tools just in a second. So the important thing is to choose the best tools for the work and then bring all the information together within the BIM model.
Yeah. Now let's talk about sun and daylight analysis and how can we use BIM to carry on this type of analysis. Even very simple sun and shadow studies can significantly improve performance-driven design decision when integrated early in the BIM process. As you can see in this slide, we have done some analysis in ArchiCAD. So it's possible to carry out some earlier stage daylight and solar analysis very quickly and effectively in ArchiCAD, and this analysis has been done for this project. Sun path analysis, how does it help us? It helps us to understand seasonal solar exposure, comparing winter and summer conditions, as you can see on the left side, and also evaluate the impact on daylight availability and overheating risk. Based on this, what can designer do? Basically, designer can optimize building orientation and roof geometry to maximize daylight while also minimizing glare and excessive solar gains, because we know we need daylight, but we don't want glare and we don't want excessive solar gains. And in this project, facade windows are designed with overhangs, as you can see on the sections, to control high angle summer sun while still allowing lower angle winter sun to enter to the space. And we also have roof windows in the project, and the roof windows, of course, due to their position, receive higher solar exposure. And this is beneficial for daylight penetration, but of course requires careful solar protection during the summer season. So you should have some solar protection shutters externally and also internally in your roof windows.
I think this is more and more important as LCA life cycle assessment is getting mandatory, because a lot of the CO2 is from heating and cooling. So we need to shut out the sun heat in the summertime, and we need to get a lot more sun energy inside the building in the winter. And this small roof overhang solves the problem with the facade windows. And the VELUX roof windows are actually clever enough to get a lot of sun in when you want, and then you just have outside shutters so the heat doesn't get in the summer period.
Exactly.
At the same time, they have this hybrid ventilation.
Yeah, as
benefit.
you just mentioned, this early sun analysis can really help us reduce cooling demand, but of course improving daylight performance, because we need to look holistically. We cannot just say we want to save energy, so close everything. We don't want windows on the roof, even though it's bringing a lot of benefits, but there are strategies to save energy.
Exactly.
In this slide, we have done some shadow analysis in ArchiCAD, and we can see comparing, let's say, March and June, there is clear seasonal differences. In summer, the higher sun angle result in shorter shadows and greater solar exposure, while in winter, lower sun angles create longer shadows. This earliest stage shadow analysis helps us guide window placement and internal space planning. So even when you are designing your interior space, you need to pay attention where to put your kitchen, your living room, where you need the most shadow in the morning, in the evening, where you need the most sun, also in the interior places. And as I said, these insights really informs key design decisions. And the south-facing roof is used for solar panels and roof window with shading. to balance daylight access and solar control, as we also discussed in the previous slide. And this analysis also show the impact of surrounding context on the facade daylight, because as you can see, this project is of course located in a real location, and we need to do this analysis on the real case to also see how the surrounding are impacting, are having shadow on our building. And this project is a villa in a low density area, and we can see how is overshadowed by neighboring building, and we can see actually this is minimal. So overall, this supports better decision on orientation, facade design, and also space planning from the very early stage. And we can also see we have done some pattern shadow analysis in another tool called Climate Studio, and this also confirms the same pattern we observed earlier. So it's just to show you can use different tools to see the result, also here like in a 3D level, and show you how sun is moving if you want to have it in your 3D model. But there are other tools out there that you can do sun pattern shadow analysis, but these two tools that we just talked about are very commonly used by architects and designers. Now we want to talk a bit about solar radiation analysis that has been done in Grasshopper tool. This actually shows how solar energy is distributed across the building surface. As you can see here, during summer from mid-May to mid-September, the south-facing roof received the highest radiation level. You can see by the color how this is actually distributed, making it the most suitable area for solar panels. For this reason, we have combined the strategy of having solar panels and roof windows on the roof in this project. But as we also talked about, the high exposure to the sun in the roof, it needs really protection. So where we have roof windows, we need to take into account some strategies to reduce overheating, and that's why we are having heat protection, that we call it shutter on top of roof window. But on the other side, if we look at the cooler period, which is from January to mid-May and also from mid-September to December, we see the radiation levels are lower, but they are still the south-facing roof and facade getting the highest solar exposure. That is really important for the passive heating. Overall, this type of analysis can inform decision on facade, roof design, window placement, PV panels integration, and shading strategies. So it's really recommended to do solar radiation analysis for your project. We have also looked at the annual sunlight exposure analysis, which has the metrics of hours, also in the Grasshopper tool. And what does this analysis shows us? This analysis basically evaluates the duration of sunlight exposure on the building surface across the season. So in summer, we can see roof and the south-facing areas again receive extended hours of direct sunlight, while in winter, the exposure is less, so these hours are basically reduced. How can we use this information? This can basically help us identify where consistent daylight is available and where adjustment may be needed to improve daylight performance, where you need to put bigger windows or smaller windows, depends on how is your internal planning designed.
But also the solar panels. And as you can see, the south-facing roof is optimal for a lot of energy consumption by solar panels. Exactly. But the north-facing roofs are actually also giving quite a lot of sun in the summertime. Exactly. And the energy you get from solar panels pointing north will be in the very early morning and in the late afternoon and evening. And that's when you need a lot of energy for electrical appliances in Denmark. Exactly. So we might have to put solar panels on the north-facing roofs in the future.
Yeah, when looking to future, yes, that makes a lot of sense. But then again, it's like, how do we balance this space on the roof to not just fill out our roof with solar panels and forget about that we could also have some opening to the sky and bring some daylight in. But like, what is the balance between saving energy but also thinking about using the most out of the free source of energy as sun?
And the great thing about the skylights is that you can shut them out on the outside when you need to, and then if you have in the summer, if you have north-facing skylights, you can still get a lot of light into your building without the heat.
Yeah, exactly. That's the value of thinking early in the design and think about all this and consider.
Exactly.
Yeah, and then I just pass it to you again, Thomas.
Yes,
continue.
Because it's not all about shape, it's also about material choices. With everything, we need to do all the choices as early as possible. And of course, that's not possible, but we can do a little bit of thinking early on to figure out how we can make this building perform well in a life cycle analysis. So when I talk materials, I always think of materials in a life cycle analysis point of view. So we have to limit the footprint of the building. And in Denmark, there are strict demands on how much CO2 a building can, the CO2 footprint can be for a building, and it's measured over 50 years. It will include the materials for the building, it will include the operational energy for heating, cooling, ventilation, and it will also include the CO2 when you take down the building in the end and have to get rid of all the materials. So we did this matrix, and there are different building parts where we have to find materials for. Insulation, construction, inner cladding, and so on. And in the same time, we have different materials that have different footprint in terms of CO2. So in the bottom of this matrix, we have the materials with the highest climate impact. And then on the top, we have the materials with a lower CO2 footprint. So in a perfect world, we would go on the top shelf only. But those materials also come with disadvantages. Some of them can be expensive. Some of them can be have difficulties with rain and moist. Sometimes we would like to have other kind of materials that we like to touch and look at. So there's a lot of different parameters that we have to take under consideration. And the ones we chose for this project is, of course, inspired of the original building, but also with a smaller CO2 footprint. And we mark them with green circles. In the Danish template for ArchiCAD, we already put in a lot of materials with an LCA considering built in. So there's CO2 values on all the Danish materials, so they would automatically be calculated when we do the LCA. If you're trying to match this workflow in other countries, you have to find EPD values. It could be from a database like the Økobau.dat database, and then enter manually into your project or into your template for further use. And we use the Design LCA calculator, which is a really easy tool to use. It's a plugin for ArchiCAD, so you don't have to leave your BIM application. You can do everything within the BIM application. It will give you the CO2 from all the materials, more or less automatically, but it will also let you do an energy calculation to see the CO2 from the operational energy. So Design LCA will give you a whole overlook of the total climate impact of your building from the very early sketches. And we'll get back to in a later seminar how this LCA calculation works with the BIM project. Then I want to talk a little bit about BIM objects. In ArchiCAD, there's a lot of built-in objects, the generic. Sometimes you need the information of specific product-specific products, and for that use, it might make sense to download from a specified manufacturer. And of course, we would like to have VELUX windows inside our model. So we went to bimobject.com, downloaded the VELUX library. Now I'm just uploading it to BIM Cloud because this project is shared between different people. So we are using teamwork, and therefore everything is shared on the BIM Cloud. So now it's uploading, and then I just add this VELUX library to my library manager and to my project. And it's not an object, it's a library of objects. And that means I get a lot more than just one window when I do this small trick. So now it's downloading again after I upload it, and I can go to my skylight tool and see what it brings. So I just have to click on the skylights, and you can see here there's a lot of other VELUX products, different windows, and a lot of tools to bring daylight and ventilation into a project. You can find the right size of window. You can change all the different parameters within the project, and there's this configuring user interface that makes it easy to adjust everything. There's even a link to the EPD, so if you want to have the correct CO2 values for the climate impact, it's there. There's also a video link, so you'll be brought to YouTube, and here you can see a small tutorial about how to use the object library, and there's also an explaining PDF. So all the information is built into the objects. But what's even more clever is there's a model view system also. So if I go to my model view options, I can go to the VELUX pane, and here I can choose what language I want the objects to be shown in, and the LOD for different drawings, and I can combine that to my layouts. And here there's also a link for the VELUX Visual Daylight analysis tool. So everything is there. So it's really easy to get all the benefits of all the work VELUX does to bring great products, but also to educate the people using their products. Next week, we're going to dive deeper into how we use the object from VELUX to detail our drawings and our project and bring information from the objects into our product material. This is just pictures from the model and from the schedules we did with the objects. So the last point of the webinar today is a little story about visualization. And I think, especially in early phase, visualization is really important. It's important for the architect to understand their project themselves. It's important that we can deliver our vision and ideas, not only a shape or some technical information, but also all the more soft information that we have concerning the project. And visualizations should be done, of course, early on, and it might be done inside BIM. It could also be done in other rendering applications, but most BIM tools have a built-in rendering functionality, so that can bring some benefits. So to use that, it's important that you set up your materials, and you have to set them up twice in ArchiCAD. First, you set them up for the hardware acceleration feature, so that's when you're working with the model. It looks almost like what you see in your renderings. And then you also have to match those properties with the Cineware system. And Cineware inside ArchiCAD is the rendering engine that does photorealistic rendering. So when you set up the materials for Cineware, there's a lot of extra functionality like bump maps and reflections and alpha maps, and it's almost, there's no limit to how much you can customize your materials inside the Cineware part. if you have the time and knowledge to do it. After that, you have to set up your photo rendering settings. So you choose, of course, the right angle, the right camera view for your project and for your illustration. And then you start adjusting the sun direction, the amount of sun, how the sky should illuminate the model. And there's also tons of settings. There are also some pretty easy presets. So built in with every ArchiCAD, there's this one we use here. The scene is called Outdoor Daylight Fast, and that's used to do illustrations outdoor in daylight, and you don't want to wait for it, so it's fast. So you don't have to make all these detail settings yourself. And there's also a small tick mark called detail settings. So if you take that away, you'll get it into a simple interface where you can just, with a slider, add more light or take a little bit light away. But of course, we're pros, so we go with the detailed one. When I have generated my renders, I can put them on layouts inside the layout book in ArchiCAD. And the benefit of that is every time I change my model and I go to the layout, or if I press print or save PDF, it will re-render all the illustrations, so I have an updated view of my model with the latest changes. That's all done automatically. The problem is sometimes these renders, they can take some time. They can take a few minutes or 10 minutes or 15 minutes, depending on the size, the resolution, and the detail level you chose. If you want it to be really high-end photorealistic, it will take more time. So therefore, it could be a good idea to choose for each illustration to have manual update. So they will not update automatically, but you have to choose the layouts with the renderings and just choose update, and then they will re-render while you eat lunch or drink coffee or wait for the next workday.
Thomas, I think this actually renderings is really helpful for early on decision making, because you can just show to your clients like what are the reasons behind your choices in terms of material choice, in terms of placement of your, let's say, window, and you can also show the daylight provision indoor. And I think a lot of times these renderings helps to basically justify very well why did you choose differently to your client, and you cannot always show plans and 2D drawings. And I think it's really good if you have a quick way to do the rendering and just go to your discussion with your clients. And it's really nice that it's integrated in this tool, because it's also very difficult to import, export to different softwares, because there are many softwares doing visualization. I really like these features that is also getting updated based on your changes.
Exactly. And I think that architects are really good at telling themselves and each other that we don't need 3D to evaluate our projects, because we understand drawings and we have everything in our head.
Yeah.
But I know that these visualizations also benefit the architects. Does it look like this? Oh, does the sun come in like this? Should we change something? Oh, this staircase, is that a good place or not?
Yeah, exactly.
So I think it helps everybody to have nice looking visualizations, but also to communicate the project to others. Yeah. So I totally agree. So this is just a zoom in on the visualizations. And yes, they can be better. There are other tools that can do even higher end rendering than ArchiCAD can. And sometimes it's also beneficial to take your renders to Photoshop, and you can adjust lighting, you can add some extra stuff. But moving the project to another rendering application, waiting for the renders, saving the renders, opening up in Photoshop, changing something, every time you have a change in your project, that will prolong your workflow, that will slow you down. Another thing is that if you don't need another application and you don't need Photoshop, you can just move the camera, do a new or an extra illustration, and add that. You don't have to have this complete workflow working. So there's, of course, as everything, some benefits and some disadvantages to rendering inside your BIM application that you need to consider before you go on. So that actually brings us to the end of the webinar for today. So we just want to summarize. We think that BIM is the perfect tool for early analysis. So that means you have to sketch there. It doesn't make sense for us to sketch in another tool. But of course, when you need to do something that other tools does better, that could be the Ladybug climate analysis in Rhino, or the Climate Studio for more advanced solar analysis. Of course, you just move out, but then you do an export from the BIM as the groundwork, so you don't have to remodel and re-enter data every time. It's important to set coordinates correctly early on. That will save you for a lot of problems. All larger projects I've been on, there's been some difficulties between the architects, engineer, landscape architects, and interior architects about how to coordinate the 0.0. So if the architect does this based on the land surveyor's drawings really early on, everything just works.
Yeah, and I think also it's good to do, like, as we discussed, the climate analysis, the microclimate analysis early on. All the sun, wind, radiation, daylight analysis, they really help the designers to have decisions that really impact the result of the project significantly.
Definitely.
In terms of energy, in terms of daylight provision, in terms of design and making your client happy, not just by the look of the building, but also the performance of the building.
Exactly. And the alternative to do this early on is to do it late. So if you do it late, it's not a tool, then it's just documentation. So then you just have to cross your fingers that all your decisions you took while your eyes shut, they will bring you to the right place.
Exactly, yeah. Yeah, I mean, you can just continue with the...
Designing for performance, that's a key feature already for all buildings, but it's getting more and more important. As Shivani told us, the cooling, the need for cooling will double in the future. So we have to understand how we can keep sunlight out in the summer, how we can bring more sunlight in the winter, and how we can have natural ventilation combined with the technical or mechanical ventilation on the projects.
Yeah, also with all the regulation and a lot of things that designers should take into account, it's good to think about using the natural resources again that we have, like wind, sun, and not just relying on the mechanical solutions. Because as we said, with the energy consumption like the limit values, and also with the sustainability, we really need to think about these things and how can we be more smart and design better.
And of course, part of that is also the building materials. And it seems to me that the industry right now is looking only at materials. We need to build in wood, and then the shape of the building and placement of windows, and nobody cares about that. It's just moving to new materials. And I think we see it the other way around. It's important to do these early analysis of the microclimate. It's important to do the design of the building's geometry, and then we talk materials. And the last thing we learned today is the power of BIM objects. I think that the advanced objects inside ArchiCAD are really helpful, but of course you get a lot of extra information and benefits of having the manufacturer's optimized objects that will both deliver information but also the right geometry for visualization along with functionality as outside shutters and so on. So that's all for today. Before we jump to the Q&A, I just want to make sure that everybody knows that next week, Friday, April 24th, we have the next webinar ready. And you can sign up directly on LinkedIn. We're going to be talking about how to detail the project. So sketching was today, next time is detailing. That's going to be super interesting, I think. So sign up right now, and then Elham, I don't know if you have anybody who had questions today.
Yeah, we have one question that Magdalena is asking. Is it possible to display seasonal sun angles directly in a section view in ArchiCAD as shown in the example? I think some of the work in that section was done manually.
I think so too.
Yeah.
So yes, it's possible to show it, but it's only possible to show it by reading the sun angle on the internet and then making an arrow with the same angle. But I think it's really obvious that that section that shows the hybrid ventilation with the sunlight going through the facade windows and the skylights is really important to understand how you build for sustainability. But then when you see the microclimate analysis with the Grasshopper tools, you can see, yes, but because I put an arrow on my section, it's actually not completely shutting out sunlight in the summer. There's actually something coming from lower angles in the morning and in the evening, and it's more complex. So I think it's important to do these really simplified diagrams, but also having a little bit more knowledge to base your design decisions on.
As we said, it's like earlier stage analysis. So having that as a foundation and just like draw on it.
Yeah.
But it's also ArchiCAD provides this possibility to do it in the tool. You don't need like to do it in Photoshop, for example. This.
Exactly.
Yeah. So that's also a good thing. And Arthur is saying it's possible to show sun exposure measured in kilowatt hours, and kilowatt hours may be more important than hours, because we had a slide talking about the sun exposure hours and radiation in kilowatt hours. Of course, they both bringing different insights, for decision makings. But we just show the possibility that it's possible to have BIM model imported to a tool and get to this result. But it depends on the designer choice what to start with, but I agree that the kilowatt hours.
The kilowatt hours is the energy entering into the building through the windows, and that will be important to the cooling needs and the heating needs of the building. And when we do the LCA calculations, we need an energy calculation for calculating the operational energy. So we'll get back to that in a later webinar, how that is also added. So I think that Arthur is right. We should do the other thing, but for the very early phases, perhaps the hours are most important. And when we move a little bit longer into the workflow, the kilowatt hours are actually more important.
And we have another question, say, is the Lustrup building available to download on the GRAPHISOFT BIM website?
We're just updating the landing page of the project. So if you go to velux.com and the project development guide page, there will be project materials you can download. And there will be the drawing material as a PDF. And there's also BIMX. So it's easy to download the BIMX if you just want to explore the model and the drawings together. But if you want to dig deeper into how that was made, or perhaps changing things yourself, we actually also provide the ArchiCAD model if you're an ArchiCAD user, and an IFC model if you use other tools.
Yeah, and we have a comment from...
And this is, I just want to add,
yeah, sure.
The material is, the project material is work in progress, so we'll keep updating that throughout the spring and the summer. And the web page is also a little bit work in progress. So we're waiting for the last buttons to appear with the BIMX and the drawing material.
Yeah. Yeah, I was just saying we have a comment from Eleni saying, indeed, the incident radiation metric is very useful for understanding the solar potential in sunlit vs shaded area, and it's possible to be delivered in kilowatt hours per square meter. Basically, a summary of what we also discussed, what metrics make sense to be used for what reasons. Yeah, and we have also good positive feedback, very interesting. And
Oh, I'm happy.
Yeah.
So we were actually able to do a full sketch project inside ArchiCAD. We modeled everything in 3D. We did microclimate analysis in different softwares, brought information back and forth. But we also managed to keep ourselves below 1 hour.
Yeah,
So
fine.
the webinar,
Yeah.
the webinar is over.
Yeah.
So thank you so much for staying so long. Perhaps you are watching the recording on the VELUX landing page for the development guide. Make sure you sign up for webinars in the future. As we told you, there's going to be 5 more webinars. It's going to be Fridays during the spring, and we'll move on with detailing LCA, MEP, structural analysis, and everything else that is in the whole project workflow. Thank you so much, Elham.
Yeah.
Thanks to Shivani, who was also in front of the camera. Thanks to Alberta and Lorena, who's been in the back end making everything work. And we hope to see you next Friday.
Next Friday. Yeah.
Thank you. See you all.
Bye.